Hi, my name is Isabel Tsang, and this is my Grade 12 Calculus CCT. The purpose of my video is to give a full step-by-step explanation of how to solve an exponential function equation. The question I will be solving for you today is from the McGraw-Hill Calculus and Vectors textbook. It comes from the review of Unit 5, Exponential and Logarithmic Functions, and is question number 10 from page 296. The question states, a sample of uranium-239 decays into neptunium-239. According to the standard decay function, n of t equals n subscript o e to the power negative lambda times t. After 10 minutes, the sample has decayed to 64% of its initial amount. A. Determine the value of the disintegration constant, which is lambda. B. Determine the half-life of U-239. C. Write the equation that gives the amount of U-239 remaining as a function of time in terms of half-life. D. Suppose the initial sample has a mass of 25 milligrams. How fast is the sample decaying after 15 minutes? As you can see by looking at the equation we are given, it is an exponential equation with base e. And subscript O is the coefficient, or initial amount. When I graph this equation, we observe this graph as a decaying function. On the graph's x-axis, it represents the time in minutes, and on the y-axis, it represents the amount of uranium left in milligrams. The calculus concepts used today are natural log and constant e, used in parts A, B, C, and D, rewriting an exponential function with a different base than given, used in part C, and differentiating an exponential function, which is seen in part D. Let's start by understanding the terms I will be discussing today. In today's question, we will be using the constant base e. Natural log is the logarithm of the base of e, and constant e stands for Euler's constant. Euler's constant is an irrational number with a value of approximately 2.72. Euler's constant is the ideal base, and it can help us determine the derivative of any exponential function. The derivative of Euler's constant is the same as the original equation because the slopes x and y values are the same. Now let's start solving. Starting with A, determine the value of the disintegration constant lambda. In our equation, lambda is in the numerator. We have to isolate for a variable in the exponent of an exponential function with base e. Let's go over a quick and easy example so we can get a deeper understanding of taking a natural log. The example we will be looking at today is f of x equals 2 base e to the power x. We are told to solve for x and that f of x equals 3. We will use the natural log to solve for x. We start by substituting the 3 into the equation, and now we try to isolate for x. I start by dividing both sides by 2 so that 3 over 2 equals e to the power x. Now you might seem stuck, but we need to bring the coefficient down. To do this, you have to take the natural log of both sides, ln, and then you can bring the exponent down to the front. This creates ln 3 over 2 equals x ln e. But ln e equals 1, so we get ln 3 over 2x. And then we simplify that, and we get x equals 0.41. A. The question is asking you to solve for lambda when the sample has decayed 64% of its initial amount after 10 minutes. I am going to assume that the initial amount is 100 milligrams. My steps for solving this problem are 1. Identify given required. 2. Solve for 64% of the initial amount. 3. Sub the solved amount in as the y value. 4. Solve for lambda / the disintegration constant using natural log. And 5. A therefore statement. 1. Identify the given and required. N of t we don't know, but we can solve for as it is 64% of the initial amount. The initial amount is 100 milligrams. Lambda is what we are asked to solve for, and t is 10 minutes. Step 2 is solving for 64% of the initial amount after 10 minutes. To do this, I know that 64% in decimals is 0.64. I then multiply the initial amount of 100 milligrams by 0.64 to get 64 milligrams. Now I know that 64% of 100 milligrams is 64 milligrams. Step 3 is sub the solved amount in as n of t, and sub all other known values in. I then get 64 equals 100 e to the power lambda times 10. Step 4 is solving for lambda. I start by dividing both sides by 100, so 64 over 100 equals e to the power negative lambda times 10. To get the exponents down, I ln both sides, so ln 0.64 equals negative lambda times 10 ln e. I then simplify the ln to get negative 0.45 equals negative lambda times 10. Then divide both sides by 10, so negative 0.045 equals negative lambda. To make it positive lambda, I divide both sides by negative 1, so that 0.045 equals lambda. Lastly, step 5 is the therefore statement. Therefore, the value of disintegration constant is 0.045 per minute. I will be using the calculated disintegration constant for the rest of the problem. Now on to B. The question is asking you to determine when the half-life occurs, what value of t. We are solving the equation the same way as part A, except we are isolating for a different variable in the exponent. My steps for solving this problem are 1. Identify the given and required, 2. Solve for half of the initial amount, 3. Sub all known variables in, 4. Solve for time, and 5. Therefore statement. Step 1. Identifying given and required. N of t we will solve for as it is half the initial amount. The initial amount we assume is 100 milligrams. Lambda we solve for in part A is 0.045 per minute, and t we want to solve for. Step 2. Solve for half the initial amount. To do this, I know that 1/2 is equal to 0.5. I then multiply the initial amount of 100 milligrams by 0.5 to find half that amount. Now I know that half the initial amount of 100 milligrams is 50 milligrams. Step 3. Sub all known variables in. I now just calculated the amount of U-239 left at its half-life. That is my y value, so I sub it into the equation. I do not know the t value, which is when it occurs, but I do know the disintegration constant and the initial amount. Step 4. Solving for time. I start by dividing both sides by 100, so 50 over 100 equals e to the power negative 0.045t. Then to bring the exponent down, I must ln both sides, so ln 50 over 100 equals negative 0.045t ln e. I then simplify what I can, so ln 0.5 equals negative 0.045t. To get to the final line, I must ln 0.5 and divide both sides by negative 0.045 to get t equals 15.4. Lastly, step 5, the therefore statement. Therefore, the time when the half-life occurs is 15.4 minutes after U-239 starts decaying. We can confirm by looking back at the graph that when the sample of uranium has reached 50 milligrams, its half-life, the time it is at 15.4 minutes. Now, part C states, write the equation that gives the amount of U-239 remaining as a function of time in terms of its half-life. The question is asking you to rewrite the equation in terms of base 1/2. I am going to assume that the initial amount is 100 milligrams and that the disintegration constant is 0.045. My steps for solving this problem are 1. Use log loss to turn base e into 1/2. 2. Simplify the exponents. 3. Therefore statement. Step 1. Use log loss to turn base e into 1/2. I use the log law b to exponent log subscript b x equals x. I know that my x value is e, and the new base that I want, b, equals 0.5. I then sub my variables into the equation to get 0.5 to exponent log subscript 0.5 e equals e. This is my new value for e. Step 2, I sub my new base into the equation. I knew that the base that I solved for in step 1 is equal to e. I then sub it into my equation. N of t equals 100e to the power negative 0.045t to get 100 times 0.5 to the exponent log subscript 0.5e to the exponent negative 0.045t. Step 3, simplify exponents. To simplify, I use my exponent rules and I must multiply both exponents to get 100 times 0.5 to the power negative 0.045t log subscript 0.5e. Lastly, step 4, my therefore statement. Therefore, the equation written in terms of base 1/2 is n of t equals 100 times 0.5 to exponent negative 0.045t log subscript 0.5e. To check, I graph both the functions, the original one and the one with a base of 1/2, and you can see through the graphs that they are identical. Lastly, part D states, suppose the initial sample had a mass of 25 milligrams. How fast is the sample decaying after 15 minutes? I have to solve for the derivative because I'm finding how fast or the rate at which a sample is decaying at a certain point. Let's go over how to differentiate exponential functions with a base e. Using a simpler example, f of x equals 2e to exponent 3x. Now to differentiate this, we have to first start off by identifying the base. The base is e, which is the ideal base. Now we have to multiply the whole function by the derivative of the exponent. The exponent is a function. 3x is a line, so the derivative of 3x is 3. So we multiply the entire function by 3, and because 3 and 2 are both coefficients, we multiply them together to get 6. We leave the base e by itself and the exponent alone, so we are left with f prime x equals 6e to exponent 3x. And this is how you differentiate exponential functions with base e. Now, in the question that we are actually solving, you are given a different initial amount and you are given a time. You are asked to calculate the rate, which is variable t, at which it is decaying. My steps for solving this problem are 1. Identify the given and required. 2. Solve for the derivative. 3. Sub in the time into the derivative equation. 4. Solve for the y value. And 5. A therefore statement. Step 1. Identify given and required. We know that the initial amount is 25 milligrams. We know lambda is 0.045 as calculated in part A. N of t we are going to solve, and t equals 15 minutes. Step 2. Solve for the derivative. I sub our known values, the initial amount and lambda, into the original equation to get n of t equals 25 e to the exponent negative 0.045t. Now, to solve for the derivative, I must multiply the entire equation by the derivative of the exponent. The exponent is negative 0.045t, so the derivative must be negative 0.05. I then multiply the coefficients together, 25 times negative 0.045, to get the entire derivative equation of negative 1.125e to exponent negative 0.045t. Next, step 3, I sub the t value into the derivative. So the first derivative on t equals 15, I get the equation negative 1.125e to exponent negative 0.045 times 15. Step 4, solve for the y value. This is just simplifying the entire equation. I start by multiplying the exponents together, negative 0.045 times 15. I get an entire equation of negative 1.125e to the exponent negative 0.675. When I solve for this, I get negative 0.5728. Lastly, the therefore statement. Therefore, the substance is decaying at a rate of 0.57 milligrams per minute at 15 minutes when the initial amount is 25 milligrams. A career that would use exponential equations with natural logarithms is a nuclear chemist. The question we solved today was very similar to a problem that a nuclear chemist may run into. Nuclear chemistry is the branch of chemistry that deals with nuclear reaction or those reactions that take place inside atoms. As such, nuclear chemists are involved in several areas of research, from nuclear imaging in medicine to nuclear engineering and power generation. Nuclear chemists look at decay of natural material and use exponential equations to solve for reactivity and times of reactivity. Thanks for watching!